Dear students, in part first of the vibrational energy level, we discussed about the angular velocity and the frequency of the diatomic molecule, which act like a simple harmonic oscillators. That is, its angular velocity omega was equal to the k divided by mu under root, and its angular velocity mu naught was equal to the 1 by 2 by k over mu. Now we go to the quantum mechanical treatment of vibrational energy of the diatomic molecules, that is quantum mechanical solution. Okay, so here again we consider the two molecules consist of two atoms of mass m1 and another atom of mass m2 that are separated by the distance r. When we stretch the molecules by increasing the distance, that is when we increase the distance between the two atoms of mass m1 and m2, and this distance is r0, and this can be represented by the r. So by stretching the molecule, we store the potential energy within it, and this potential energy, the relation between the force and the potential energy is like F is equal to minus du divided by dx. This one is equation number 1, and according to Hooke's law, F is equal to minus kx, and this one is equation number 2. Now we have the two equations for the force, so we can equate the equation 1 and equation 2. So by equating the equation 1 and equation 2, we have minus du divided by dx is equal to minus kx, and we can write it like the du is equal to minus kx into dx. This one is equation number 3. By integrating this equation, we get like the u is equal to 1 by 2 kx square. Now the x is the distance distance which is equal to u is equal to 1 by 2 k into x minus r naught into whole square. So as we are solving it by quantum mechanical solution, so in quantum mechanics we have the Schrödinger wave equation. Schrödinger wave equation is t square psi over dx square plus 2m over h square into e minus u, and psi is equal to 0. Here this one is the energy, psi is the wave function. Now putting the value of u, we have t square psi over dx square plus 2m over h square into e minus 1 by 2 kx square into psi is equal to 0. This one is the Schrödinger wave equation for simple harmonic oscillator. That is, now we need to solve this equation for the diatomic molecule by considering the diatomic molecule as simple harmonic oscillator. So we have the equation like simple Schrödinger wave equations: d square psi over dx square plus 2m over h square into e minus 1 divided by 2 k x square into psi is equal to 0. That is equation for the simple harmonic oscillator for equation for Schrödinger wave equation for simple harmonic oscillator. Now the solution of this equation is E n is is equal to n plus 1 by 2 into h mu naught. This is the solution of Schrödinger wave equation for simple harmonic oscillator, and we consider it like the equation A. Here mu naught is the frequency and this h is the Planck constant. Here n we call n as the vibrational quantum number. It gives us the information about the vibrational energy level. So this one is the vibrational quantum number, and its values can be the 0, 1, 2 up to so on. So in equation A we can put the different value of the n and we get different energy levels. Like by putting the n is equal to 1, n is equal to 0, we get E naught is equal to 1 by 2 h mu naught. So this is the energy of the lowest energy level, vibrational energy level, and this energy is also called as the 0 point energy. This is also called as the 0 point energy, and we call it the 0 point energy because at at the lowest energy level, energy is not equal to 0, but it has some value. So this energy is called as the 0 point energy. So for n is equal to 1, the value of energy will be equal to the 3 by 2 h mu naught, and in the same way for n is equal to 2, we have the value E2 is equal to 5 by 2 h mu naught, and in the same way E3 will be equal to the 7 by 2 h mu naught. So we can get the value of different energy space. Here from the value of energy, that is E naught is equal to 1 by 2 h mu naught, E1 is equal to 3 by 2 h mu naught, E2 is equal to 5 by 2 h mu naught. Here you can see that the energy levels are equally spaced. Energy levels are equally spaced. So we can also find it like we have E1 minus E naught, then 3 by 2 h mu naught minus 1 by 2 h mu naught is equal to h mu naught. In the same way, E2 minus E1 will be equal to the 5 by 2 h mu naught minus 3 by 2 h mu naught, so equal to h mu naught. So the difference of energy between two levels is always equal to the h mu naught. So we can say that all energy levels are equally spaced energy levels. So in the next part of this video about the vibrational energy level, that is in the part 3 of our video, we will learn about the energy level diagrams and about the selection rules. For more information about the vibrational energy levels, please watch our next video, that is the part 3 of the vibrational energy level in the diatomic molecule.